Here the problem reads, look at the factor tree, and here we have a factor tree with 18 at the top, broken down into two factors, 6 times 3, and then the 6 is not prime, so it can be broken down into 3 times 2, and then the 3 is prime, so we're copying it down here, so that at the bottom we get 3 times 2 times 3. And then we read that we're supposed to complete a similar factor tree for the number 20 using multiplication. Well, let's begin by highlighting the key part here. And the key part here is for us to complete a similar factor tree for the number 20 using multiplication. Alright, so let's go ahead and write the number 20 down here. And I'm actually going to show this two ways, but you would only need to do one of these. So let's start with 20. Let's see, one factor pair for 20 would be, say, 4 times 5. And you can put the times in here. It's kind of optional. And then, let's see, 4, is that prime? No. 4 can be broken down into the product of 2 times 2. And then 5. Well, 5 is prime, so we'll copy it down here. And then we'll put a times in between here. So 20, one way to write 20, is 2 times 2 times 5. Okay, and then here's kind of an extra piece. Let's factor 20 a different way and see if we get the same product of prime factors that we do here. So let's see, 20 could also be broken down into, say, 2 times 10. And then 2 is prime, so we just copy it straight down. And then 10 is not prime. 10 is 2 times 5 or 5 times 2. If we wrote it as 5 times 2, and we can put the times in here, and here, and here as well, then we would get 20 is equal to 2 times 5 times 2. Well, because multiplication is commutative, we could certainly rearrange and put the 2 times 2 first, and then that would leave us times 5. And that is identical to what's over here. So it doesn't really matter how we factor numbers into primes. At the end we'll get the same set of prime factors, and if we write them in order, we'll get the identical prime factorization. So that's our final answer here.